Hey guys, so today you and I are going to talk about quality. So let's get into it. So the question in question was, Frederick, would you say that is investment in software engineering quality an investment in productivity and cost saving? Yes, more or less I would say so. The idea being that if you increase the quality of like your software developers and your processes, you will maintain a lower level of complexity within the system, which basically, because usually the thing is, as the systems grow larger, it takes more and more time and effort to maintain them, and changing code becomes more risky because anything can break. If you have a very small system, you can sort of understand if something's going to go bad when you change something, so it's fairly low risk. But in a really large system, it's very difficult to know if something is working when you change something that has like a long spanning effects that can affect many parts of the system. And so that's a very big reason as to why we invest in software quality. The problem is usually though that there's well, let's just say that it's a very difficult beast to tackle. And it's the same thing with productivity. Like usually when you're investing in software engineering quality and like in better improved systems, you're looking for some metric that you want to deliver on, and it can be revenue, for example, like you want to sell more systems or you want to sell more services or whatever you're doing. It depends a little bit on what your business model is. So it might be the question that you're trying to increase productivity for like your users, like there's some value that you're looking for. But the productivity could also be that you have internal systems, like you have workers who work with systems that you have in-house or something like that, and you want to improve them so that they can work more effectively, for example. That's also something that is worth so quality is a very broad term, as I hope everybody can agree on, and it can mean quite a lot of things. The thing that is worth knowing though is that it's a notoriously difficult thing to figure out how to actually make these changes effectively. I would say that is probably the most complicated thing for a lot of IT companies. Because when you talk about quality, it can mean quite a lot of things. I mean, the average software developer is going to be able to tell you a few basics about how to fix things, if that makes sense, like adding unit tests or like these like automated tests, etc., etc. These sorts of things are simple things that you can do in order to increase the overall quality. But then quality works not just in terms of testing, that's just one part of it. Then you have things like quality of like the work process of the teams, how effectively are they working with things, how effective are the stakeholders at communication and like setting expectation on what should be delivered, how well do they understand the users and the needs of the business, so that you can actually build the right thing, because that's something that I think has more to do with anything else. Testing and so forth are very important factors in order to assure quality, but the most important thing is system design. Because this is sort of like what I think at the very least, if you build the wrong thing, nothing else matters. If the thing that you made is like poorly designed, like you can have the best engineering team in the world or like the best testers or like the most extensive test suites in the world. It's not going to change anything because you have fundamentally created a solution to a problem, and the solution is not good, which means that it's not going to scale over time all that well. And this is the thing that usually happens, unfortunately. And I'll share my thoughts a little bit on why I think it does happen, and sort of why it becomes almost impossible to fix. And what happens, which is actually the norm for most IT companies, is that somewhere along the line you deal with a problem that forces you into a situation where you're either dealing with a person who is incompetent or like doesn't really know how to solve this problem, or you're dealing with a stakeholder, like a requirement specification that isn't really the thing that you need to deliver. There is a mismatch in what the end consumer of the system wants or needs and what gets delivered at the end of the day. when that happens, you're in a state where the user isn't super happy with the thing, and you might not be like, it depends on you're happy if the user is happy or not, but basically you arrive at this sort of compromised state. Now, when you're in that compromised state, usually the next project comes along. So what happens is that you get sooner or later to a point where you realize that you only have two options here. Either you have to redo some stuff at a cost, of course, or you have to add new functionality or like the new requirements on top of the things that you already have. And here is the thing that's usually very telling. What usually happens is that there is a lot of incentive to never undo or refactor or fix like issues that you are missed in the problem domain or so forth. Like, as I like to say, you don't fix the real problems. You simply try to find workarounds around the real problems. And that can happen at the code level and at the product level. The classic one is that you have a product, a system like these highly complicated systems that just grow into behemoths. The reason why they keep on growing is that the people who are designing them usually may or may not know, or may not have an easy way, or like a least effort solution, a least effort situation to get to where they need to get. Or they might not be able to talk, they might not actually talk to the consumers and actually have a good rapport with the consumers, understanding their problems and actually designing good products. And so the design might be compromised from the get-go, and that cascades all the way through the code. But then you can, of course, as I said, also have like developers who have a lot of bright ideas and actually create a lot of technical depth or like legacy, not because the system itself is bad, but because they themselves may not be all that good at what they're doing, or like they might take a lot of unnecessary risks, etc., etc. And so what then happens is that the as I was saying, the work for you to undo that is so high that you usually just add things on top. Like you simply continue working with the existing framework that you've already created, and that continues until you get to one magic moment. And that magic moment usually is you want to build something on behalf of somebody, and they give you a specification of what they want to happen, and you can't make it happen because the system is designed in such a way that that specific thing cannot be done in a ready fashion. And now you have reached the point where I say, now this is where quality has degraded to the point where now you can't make the system do what you want because you have skimped on quality at every stage of your delivery cycle, both usually at the product design level, at the technical architecture level, etc., etc. The testing is like it's almost circumstantial at this point. The testing is like the last little thing you're doing, but all the other stuff has been compromised to the point where the system can no longer be made to do the thing that you want, and so you have to compromise with the product quality itself. And that, my friend, that is where the vast majority of IT companies find themselves when they have skimped on quality for long enough, where they have a business need or they have a need to build something and they can't do it because they've basically built a system that where the cost of fixing the underlying problems that they have in order to actually accommodate like these the needs that they want to create has become so costly, like that it can't be done basically in a readily fashion. And then usually what happens is that they need to make a choice. Either they try to create some type of workaround solution again and see if they can find some other angle, or they compromise with the product quality, like they basically try to create something that is not exactly the thing that they want, just something that is close enough or something that works well enough, and then it continues. And that compromising, you find these sorts, the most telling situations where you find this sort of stuff is in large corporations who don't have who are not quote unquote true IT companies, because usually it's cheaper for them to avoid, like, because like their products are usually not the digital systems themselves. it is what they are using in order to sell their products. And as long as the customers are happy enough, they're going to be able to continue doing that. The issue is, as I've said, the cost of that over time is so enormous that you have entire companies who are getting disrupted at this point by IT companies, because the IT companies have understood that in order for automation and like IT and so forth to be that gigantic boon to your company, you have to actually make it a boon, because you can fuck up you can have a productivity level that is on par with what you had before, almost what you had before computers. I'm not going to go that far, but you can basically see no return on investment on software quality investments if all you're actually doing is cherry picking the quality, quote unquote, quality issues that have almost no impact on the overall quality of your system. It's sort of like splashing at the very top of the water. You're not actually you're not getting your hands dirty. You're just doing this easy stuff on top, because the reality is that in order for you to fix the fundamental problems that are actually going to give you that really big return on investment and get you that productivity and the cost savings and so forth, you have to make an investment into something that you might not be qualified to fix. Bottom line, it comes down to that, because some of these really large systems, guys, some of them are so large and so complicated that the likelihood of you finding, having just one person who's really, really talented is not enough to fix that problem. You need to have multiple people that are really, really good at this sort of stuff. And let's just say that there's not enough of those sorts of people going around in IT for it to be consistently a consistent bet that you're going to find those people to fix your company's problems. So what I want you to take away from this is that yes, usually when you invest in quality, software engineering quality, you're trying to achieve some type of productivity or cost saving or increased revenue or something like that. The problem that people have usually with this is that we simply don't know how to find that perfect combination of product people and engineers who are very suited to fix or build the sort of systems that can scale and can continuously keep down costs and increase productivity, because it's actually a very, very complicated problem. And it's not just an engineering problem, guys. It's a problem that goes all the way up to product design, where you have people who design classic, as I said, you have architects or product owners or people like that who design entire systems or entire solutions without even talking to the developers. A classic one, if you ever take designers as an example, how many designers have you talked to who go and design and you ask them for you have an existing system and you ask them to design something on your behalf, and then they design the thing without actually ever talking to the people who actually, like the developers or any of the people who are working with the system and so forth. So they might design something that you can't really build for them. It's exactly this problem where you have this decoupling between the people who plan things, the people who are going to consume it, and the people who are going to build it. And that is a constant problem. There is it's sort of the idea of cross-functional teams and people working together in this on this thing to sort of mitigate that problem, because that system of handing off and this phase shifting things is it's the thing that leads to what I was saying. You make something, you design something poorly, and that poor design then grows over time until there's a mismatch between what your system does and what your business requires it to do. And when that has happened, well, no QA in the world, no tester or so forth is going to be able to fix that. What's going to have to happen is that you're basically going to have to scrap the project or redesign it or reimagine it, or at the very least you're going to have some very talented software engineers go in and take care of some very fundamental problems, and the cost of that is going to it gets to be fairly high, and it's not all companies who want to pay that sort of cost. Have a great day.